Hi, my name is Andrea McGowan, and my project is titled The Development of an Immunosorbent Assay for the Detection of IgG and IgA Antibodies against Tissue Transglutaminase for the Diagnosis of Celiac Sprue. My project originated because several members of my family have celiac disease, and it is also very pertinent in today's society, with about 1 in 133 Americans having it and about 83% of those being misdiagnosed or undiagnosed. My mentor was Mr. James Freeman. He is the Senior Director of Immunoassay Developments at Siemens Healthcare Diagnostics in Tarrytown, New York, which is where most of my laboratory work took place. He provided me with journals, new tools and technology, and insight from past work with ELISA tests. Because of the rate of misdiagnosis, my goal was to create a more accurate test. So as you know, the immune system is made up of billions of B cells, and when the immune system is invaded by a virus, that B cell binds to that virus and triggers a series of events which creates antibodies, allowing macrophages to come destroy the virus because the antibody binds to that specific antigen or foreign invader. In celiac sprue, that antigen is tissue transglutaminase, or TTG. TTG is the enzyme that breaks down the protein in wheat. With antibodies attacking TTG, the body is unable to break down wheat. IgG and IgA autoantibodies are the antibodies in this case that attack TTG. With this information known, an ELISA, or enzyme-linked immunosorbent assay, was deemed appropriate. A polystyrene microtiter plate is utilized because it is very hydrophobic and TTG will stick to the plastic wells. The plate is blocked with a phosphate-buffered saline solution containing bovine serum albumin, or BSA. BSA is used to prevent any other nonspecific proteins from binding to the plate. When a human sample is introduced, the antibody in the sample, IgG or IgA, will bind to the TTG immobilized on the plastic. IgG and IgA act as the primary antibody found in the human sample. Goat anti-human antibody conjugate, specific to human IgG or IgA, is conjugated to an enzyme, alkaline phosphatase, or ALP. The enzyme acts as a signal-generating compound. Color is generated when PNPP is added to the ELISA wells after the conjugate has been added and any unbound anti-human IgG or IgA has been washed away. The ALP catalyzes the reaction of PNPP and water to form paranitrophenol, PNP, a monoester. PNPP is colorless, so any wells that contain ALP will react to form the yellow PNP, indicating positive results for antibodies to TTG and thus celiac. It will yield a yellow end product that can be read with a plate reader at 405 nanometers. The higher the concentration of IgG or IgA found in the serum sample, the stronger the color change and the sample will test positive. Optimization of test reagents was required in order to read a specific optical density, delineating positive and negative samples. After several trials, it was determined. A calibration curve was also created, and the pool was assigned a value of 300 arbitrary units per milliliter. It was assigned because no reference material is available that could produce a precise numerical value for the dose response to be confirmed as positive. With this dose response curve created, 25 known samples were tested accurately, thus deeming the test created appropriate for diagnosis